All right. So today, by the way, today is the 26th all day long. You should get out your 2-6 notes because you should already have those from yesterday.
I definitely thought it was my favorite.
You should get out your 2-6 notes. I see people without their notes out that are just staring like they're not hearing the words coming out of my mouth.
I'm getting there.
Then, by the way, I forgot this is my bad, up here, put a 2-6. Because I forgot to put that in the document. So on the top of your, especially with the fact that we just had an organization check this morning, it's important to have things labeled so you can keep things in the correct order. So please make sure that is there. So now the last thing we talked about yesterday was this scale drawing. I guess I didn't realize that it has that little yellow box around it. And we figured out the bed can fit, right? Because when we have a scale that uses 1, what's the nice thing that we get to do when we have a scale that uses like 1 inch equals 10 feet? And then I look at something like 3/4 of an inch or a 1/2 of an inch. Like, what's nice about that? Jeremiah?
It can be multiplied by 10.
Yeah. Because I have 1 inch, this is like a unit rate, I can just take however many inches I have and multiply them by 10. Now, if that's not 1, it's not as easy.
Wait, okay, so could you like 3/4? Could you say that's 3/4 of an inch?
Mm-hmm.
So it's like, then you do 3/4 of 10 feet?
Yeah. So 3/4 of 10 feet, what we solved yesterday was that this section was 7.5 feet and this section was 5 feet. And if the bed is 3 by 6, it would fit. Or 6 by 3, depending on what dimensions what order you're going in. So I guess I'll capture that just so we know. Right, if you rotate it, it wouldn't necessarily be able to fit. That comes down to feng shui, too. If you're ever looking for like a Discovery Day idea, feng shui is an interesting study of like how the design of a room makes the room feel. So in my years of teaching, like this is kind of how I best like the room, because having everybody's attention angled towards the middle, but yet you can angle it towards your peers because we want you to be able to see each other when you're talking. So that's I think this room has good feng shui. But yeah, that's another Discovery Day idea if you need. Monica?
My mom took a feng shui class last week.
Yeah.
I don't get it because it seems stupid to me.
You just don't get it yet.
I don't get it.
Yeah, there you go. So be careful with those statements of it seems stupid to me, because that's kind of rude.
Well, that's personal opinion.
Yeah.
Did you like have like the desks were like all like facing and they were like all and there was like
Yeah.
over around us?
Like, I mean, this room wouldn't really work with like, I mean, it would work, but if I just had like straight rows, like that row over there, you'd be staring at the chalkboard that I don't really use. Like, it wouldn't make sense. Or you'd have to turn your body and then it'd feel uncomfortable. So I wanted you guys to be comfortable but be able to focus. So, using this same blueprint of the apartment, in that apartment, the walls are 9 feet high, and we want to put a double coat, because most of the time when you paint, you got to paint twice, on the longest wall of the living room. A gallon of paint can cover 350 square feet. Will 1 gallon of paint be enough? So I'm going to help you guys set this up, but then I'm going to have you guys solve it on your own. So the long wall of the living room. What does the long wall of my living room measure in the drawing? Flynn, which is my long wall? How long is that? Of the living room. The longest wall of the living room. Yeah, the bottom wall. What's it measure in the drawing? 2 inches. So this is going to be my first reference point, is my wall is 2 inches long in the drawing. A niche. How do you know? Yeah, if you're still setting this up as a proportion, which you want to be familiar with, we could set up 1 inch over 10 feet. That'll be equal to 2 inches, however many feet that is. We see that on top we double, so on bottom we have to double. This must be actually 20 feet long, and we know that 1 apostrophe is how we can represent feet if we don't want to write it out using letters. Dom?
I think there's could you set it up like 20 feet times 9 times 2?
Because I was about to let you guys Let's say 90 seconds, 85 seconds actually. Try to solve this. Will 1 gallon of paint be enough? You may check with your neighbors close to you. So Sean, when I go to find the area of the wall, what do we do to find that area?
Length times height.
Length times height, or whatever 2 dimensions you have. But here I know if I'm looking at a wall, it is a certain length, it has a certain height. So you did 20 times 9, and you got what? 180. 180 feet squared, or we can say square feet. I like to do feet squared so that I can use my exponential notation. Then, Jaslyn, what do we need to do?
We need to multiply that times 2 because it's a double coat.
Yeah, if it's a double coat, I have to actually multiply that by 2, which gives me that in total the square footage that I'm covering
360.
is 360 feet squared. Now this is when being an adult is very hard. I'm not joking. Would you buy 1 gallon or 2 gallons?
1 gallon.
Oh, no, you buy 1 gallon and like another like smaller gallon or like.
Well, I mean, when you go to a paint
Still
store, it's not
be
just
way
gallons.
too
Some are
much.
gallons, some are like pints, some are.
Yeah.
So you normally can get paint in gallons or quarts. How many quarts are in a gallon? 4. Now here's the crazy thing. I go to the paint store, gallon of paint's probably like $23. The cheaper paint. That's actually cheap paint. So a gallon's $23. The quart is probably about $9 or $10. So if I buy 4 quarts, I'm going to pay way more than the gallon price. This comes down to unit price, and like when I buy a larger quantity, I can save money. So the problem is if I buy a gallon and a quart, that's okay. But if I have to go and back and get another quart, I'm going to end up spending more money than if I would have just bought 2 gallons. Here's the other tricky part, though. I'm only 10 square feet away from 1 gallon, like, being enough. If this was me, by the math, is 1 gallon enough? No. By the math, 1 gallon is not enough. But if this was me, I'd try it.
Yeah.
I would try to sneak by on just 1 gallon because their coverage estimation of 350 square feet is probably estimating on the low side so that nobody gets mad at them. Because if I buy a gallon of paint and it only covers 200 square feet, I'm going to be mad that like they lied to me on the package. So I might be able to squeeze some extra out. That's when the decision is hard. Mathematically, we should buy more than a gallon. When I actually put it into practice, I don't know. It's going to be close. Gonna be close. Now, the other dangerous thing is we did this with one of our rooms. We repainted our den, which my wife won't let me call our den, but it has a fireplace, so I call it a den. And we did the math, and 1 gallon was going to be very, very close to enough. We literally used every single drop of paint that we could. But now our wall has a scratch on it, and I can't fix it because I don't have any extra paint. So that's the problem, is a lot of times you want to have a little bit of extra paint left over so you can fix things when damages happen. So we had like a piece of furniture up against the wall. The humidity changed when we moved the furniture. The paint stuck to the furniture and it pulled the paint off the wall. So now I got to go buy a whole nother gallon if I want to fix that tiny little spot that's about that
Buy
big.
a quart and
Or I could buy a quart, but like we said, the price
Yeah, but
difference.
if you bought 1 quart, you could keep it for any other damages. But if you bought a gallon, it would like.
Yeah, and
way
it could
too
go
much.
bad. Yeah.
Paint can go bad.
Paint does go bad. Now, sometimes you can like rescue it if you mix it a bunch, but if it separates completely, it's sometimes hard to get back. It's the viscosities of the chemicals used, which you guys will, it's really the density of the liquid. So, before a trip to China, you want to exchange $1,500 US to Chinese yen. Chinese yen are not worth very much. That's why, like, think of a yen kind of like a penny. It is a small value of currency, so it takes a lot of them to make much value. So if I had $60, I'd get 384 yen. $100, 640, 150, 960. So this is our problem solving section. I want to see if you guys can do this. If you have 1,500 US dollars to your Chinese yen, I want you first to set up an equation with how many yen will you get for, bless you.
Thank you.
So instead of using y equals mx, I'm going to use y equals md. Why?
Dollars.
My input value, what I have to input, is dollars. So x is normally my input. I could use x, but it makes my life easier, makes it easier in my head if I change my variable to d for dollars. Try this on your own. First thing you want to do is figure out your constant of proportionality. Then you want to figure out how many yen will I actually have. You guys may work with partners close to you. Now be careful, yen aren't dollars. So the symbol for yen is like a Y with like an equal sign in it. Hey, be careful guys, if you're trying to notate your yen, the best that I can tell, the symbol for the Chinese yen is like the straight Y with like an equal sign through it. Don't call me during the school day. What are you doing? I don't know.
Can I answer?
Nope.
Say, hello, this is Eugene. Would you like to buy sofa?
No.
That's what it's
Because I like my sofa.
It's great.
All right, Jeremiah Smith, I feel like this is fate. Because I walked back there and Jeremiah was like, this is so easy, gosh. And now his card is on top of the stack. So Jeremiah, how did you find your constant of proportionality here?
I just did 640 divided by 100.
We know that to find our m value, and if you can't remember this, I would write it down again. It's always your y divided by your x, or in this case, our x is actually a d. So I take my yen. Now, why'd you choose this one?
Because I could figure out how many yens it would take to make $1.
Yeah, because the 100, it's super easy. So if I do 640 over 100, that's going to give me 6.4. What would my label on that be, though?
Yen.
Yen. What?
Per dollar.
Per dollar.
Is that good or bad?
Well,
There is no good or bad.
Oh,
It's
yeah.
just what it is, because the different values of money.
But you said yen isn't worth very much.
But you will get the same value of what you gave the bank. You'll just get more money to represent that same value. Does that make sense?
Yeah.
So like, if you give me $1 and I give you back 100 pennies, you still have the same amount. You just have more objects to represent that amount. That's what the difference between yen and dollars is. They have more objects that represent the same value. So we now can set up our formula that my yen will equal 6.4 times my dollars. Manos?
I did the finding the 1,500 US dollars a different way. Can I?
Finding the 1,500. What do you
how
mean?
many like you want me to get?
We're solving for yen.
Yeah. Okay, this is complicated.
Tell me what you're thinking.
Just a different way to find how many yuan you'd get for 1,000.
Did you set up the proportion equal to the fraction, cross multiply?
No.
Yeah, and then you added the zeros back on the end of it.
No.
Why not? So, I know what you're doing, but you're breaking some math rules here. This should have been divided by 100, and instead you divide that by 100. So, like, what you've done is fine if you understand it. But don't try to explain it to somebody else, because what you're doing doesn't technically make sense. Because that 1,500 does not get divided by 100. the 640 show. Because the first thing we have to do is find the constant of proportionality. So this right here, this equation, you'll have to be able to do that on the test. Okay, but then I don't understand why you're doing it this way, because you could just plug in your 1500 right here and you get your same answer, instead of doing two different sets of work. Right, so if you just do that, then you only have to do one set of work. I'm not telling you you're wrong. I'm just saying you're doing it differently. So can we stop arguing? Because I'm not arguing with you. You're trying to argue with me. We cool?
Yeah.
So then we take our constant of proportionality, plug in how many dollars, and we find out that how many yen will I be getting? Elena?
9,600.
Dang it, I got something up.
What?
Yeah, I did something wrong.
What did you do wrong? Let's find it.
Oh, I know what I did wrong.
What was it?
I didn't, trying to think of the thing. I didn't find the
Constant of
I
proportionality.
didn't find it.
So you got to make sure that you take yen divided by dollars. Whichever one you take doesn't matter. I could do the 384 divided by 60, the 960 divided by 150. All of these will give you 6.4 when you do that division. So that's what you need to check, that you can find that constant of proportionality correctly, and then plug in your input value. Yeah, Jaslyn.
I did something differently. I used the one under 100. I used 150 to
Yeah.
660 because I know
960,
times,
you mean?
Yeah, that's what I meant.
Okay.
150 times 10 is 1,500. So
Okay.
then I did
Guys.
960 times 10 and I found the amount you would get.
Oh, so here's another really great way to solve this. Jaslyn identified, well, if I have $150 compared to $1,500, that's just a difference of times 10. So here's what you really did, Jaslyn. I don't know if you set it up like this, but you probably just did this in your head. But this is the technical math of what you did. You said I have dollars on top and I have yen on bottom. So I have to have dollars on top and yen on bottom. So I know I have $1,500. How do I go from top to top? Times 10. How do I go from bottom to bottom? Times 10. So that's another route that could be taken. And this is solving directly using the proportion. The only issue here is, did we solve our constant of proportionality? No. So if you were asked for your constant of proportionality, this just didn't solve it. We did solve how many yen I will get, but we don't know our constant of proportionality yet.
And also, it's easier to find proportionality with the 640 and 100.
Right.
Because you can just move the decimal points 2 places to the right, left.
Yeah. Now the other thing, and I'm surprised nobody brought this up,
Oh wait,
Tom.
I think I just found it. But it asks which bank has the better exchange rate.
Yeah, we have two different banks here actually. So we know how many yen we'll get from bank A, but this is a different bank. So now, if we look at bank B, how do I find bank B's exchange rate? All I have is a graph. Solomon, do you know how I can find their constant of proportionality or their exchange rate? You can always pass, or you can call somebody close to you. I don't care. I got more cards.
You call them,
Ozzy?
Well, you can just take 10 and 65, then bring 65 back one decimal place.
So really, hold up. The first thing you do is pick a point at an intersection. So on the graph, I want everyone to notate this point. And that is 1065. So I know that my m is always y divided by x. So Ozzy then was saying, all you have to do is
just bring the 65 back one decimal place.
which bank has the better exchange rate? What was our constant of proportionality for bank A? Ellie?
Bank A was 6.4.
Bank A was 6.4 yen per dollar. Bank B is 6.5. Which bank has the better exchange? Bank B. So Bank B maybe updated their exchange rate more frequently, or they forgot to update their exchange rate. Maybe this was last week's exchange rate. Bank A just updated for this week, and Bank B hasn't done it yet. Yeah. And some places update automatically. Like, as the exchange rate changes, it changes. Donald, question?
I looked up the yen to dollar exchange rate.
Yeah?
One Japanese yen is worth 0.0.
Go the other way around. Because we did yen per dollar. You just did dollars per yen.
No, that's how much a yen is worth in a dollar.
I know.
A dollar is 104.23 Japanese yen.
Yeah, so this exchange rate is not close. But actually, this is Chinese yen, not Japanese yen. I think they're different.
Chinese yuan and Japanese yen.
Yeah, okay, thank you. My pronunciation is not quite on.
If a Chinese yuan millionaire went to America and exchanged all
You could buy it.
What'd you find, Dom?
That rate is actually pretty close. $1 to Chinese yen is.
Ooh, let me answer.
Only 15,000 times.
Hello? No, this is Mr. Hudson, her math teacher. Yeah, she's actually in the middle of class right now. Who is this? What? So, excuse me, why are you calling her during the school hours? I'm calling you back. Do you know a Yasmin? Yaslin? Yeah, someone? Calling you back. Hey, try the got it. Try the got it. Serious, try the got it. No, this is Mr. Hudson. I was just curious why you're trying to get a hold of Whitney. That makes sense. Well, I'm not certain. I'll discuss that with her, but she was just curious why a number she didn't know was calling her, so I'll pass that message on to her. All right. And if you could avoid calling during school hours, that would be greatly appreciated by teachers. Thank you very much. All right. Have a great day. Bye. The medical supply company, somehow they got your phone number, probably off the internet. Be careful what you do on that. So somehow they think you're having pain and need like knee braces and like. So somebody else probably had your phone number before you, but somehow your name's
I just
like.
got this phone.
Yeah.
I don't know how anyone knows my number.
So if you want, I'll show you how to. So Whitney, if you want, I'll show you how to block that number. Like, I can just block it, and then they won't be able to get through on your phone.
They called me like 15 times straight.
Because they want to sell you stuff. They're trying to sell you stuff. So they're going to keep calling.
Every single class.
They're going to keep calling until you buy something.
No, next time
Or until we block their number.
Stop calling me.
Okay, I'm going to block that number for Whitney. Once we finish this, you guys can just work on your homework. So, who... Now, hold up. This is a more in-depth problem. So you and your friend are drawing two different scale drawings. So if you've ever like tried to do a scale drawing, you know that yours might come out different size than your friend's. And actually, I'm going to post something on our Schoology page. There was this really interesting page I was scrolling through. It's a designer, like an engineer type person, made bicycles based off kids' drawings from memory. So they tried to like remember what a bike looks like, and then this dude like made them. And some of them like make no sense at all. Some of them are really cool. Yeah, exactly. So you and your friend have differences when you go to draw something. So this is your scale. This is all your stuff. This is all we have from what you did. Your friend, though, is using a scale that is y equals 1/12 x, where x is the actual distance and y is the distance on the scale drawing. X is the actual distance and y is the distance on the drawing.
I think that's a little bit I think those are flipped.
So be careful here when we go to compare y, the distance on the scale drawing. Which axis is this? X. This is the distance on your scale drawing. So you and your friend have your x and your y flipped. So be careful when we go to compare these. We're actually going to be comparing two different things. So let's solve your friend's first. Your friend's scale is y equals 1/12 x. So go ahead and write that down. Sorry, not 1/2, 1/12. She said, excuse me, it happens. Better out than in.
It's a bodily function.
Well, okay, most things better out than in. If your driveway is 180 feet long driveway, which variable on your friend's scale or your friend's equation will that 180 plug in for? Which will that plug in for? Sam? X is the actual distance, so we plug in 1/12 of 180. Monica?
Okay, never mind.
You had your hand up for a while to end up just deciding, never mind.
Oh wait, what's the question? I have the answer.
How long this will be on the drawing.
Oh, okay. You multiply 180 by 1/12, which is equivalent to 0.083 repeat.
I don't think so.
No, it's
Nope.
oh,
No.
1.15
Andrew?
Yeah, it's 15
inches.
Did you figure out what?
I was saying 1/12 is equal to that decimal.
Oh.
And I multiplied the decimal by 180.
You know you can use 1/12 in your calculator, right? All you have to do is parenthesis 1 divided by 12 parenthesis, and that is your 1/12.
These ones you can actually type 1/12.
Well, yeah, but I'd prefer you use parenthesis notation. We did the multiplication, 1/12 times 180.
I actually made another graph.
A 12th of 180, if you compute it, is 15.
She never uses calculators. She used to do everything always in her head.
So, now here's where this gets weird. I come over to this nice graph. The graph looks very, very nice, right? It's perfect up through each of these intersections. So this is like literally the best graph we can get. If available, you always want to put your dot where x is equal to 1. Moms?
I wanted to say there's an easy way to find what 180 feet would be in inches.
For here? For yours? Okay, how?
Because like for every on the map distance is if you multiply that by 10, you get the actual distance.
Yeah, so 1
So-
inch equals 10 feet.
So it's basically like dividing the actual by 10. So you have your actual distance, so just divide it by 10, so you get 18.
Yeah, so what we see here is the map distance is now your x though. So the actual distance, we could say y, the actual distance is 10 times the x, because you have to look at the graph. Your y value is 10 times the x value. So we literally just make our equation say the y value is 10 times the x value. So then, if I know the driveway is actually 180, well, that is your y value. So now we have 180 equals 10 times x, or like Manasa said, we really just need to divide by 10.
180. Well, that's easy.
What?
18.
18 inches.
Don't forget the inches. Wait,
Mr. Hudson, you didn't have to do that. You know 10 times.
I know. I just write it out so that you guys see it. I know I didn't have to, but it's good to do the work so we know what we did. Andrew?
To answer the question, yours is longer and it's longer by 3 inches.
Yeah, so on which map is the driveway longer? You have a scale that is closer to the real, because your scale is actually 1/10. Like 1/10 or 1 inch to 10 feet. is really your scale, which is just a reiteration of how I wrote it right here, just in different ratio form. So your scale is closer to the actual, which means it'll be bigger. The closer you are to the real, or the bigger your fraction is, 1/10 is bigger than 1/12, the bigger your scale drawing will actually be. Any other questions over any of this? Now, without me knowing for sure if this is going to be the test that we actually take, but I'm pretty certain, I figured I would just show you guys the test so that you're ready for it. So I know in other classes, I need to capture that. In other classes, sometimes you literally know exactly what you're going to be asked to do on the mastery, which, I mean, is fair. If you're going to be asked to show mastery of it, I don't know if that just accidentally cleared instead. But if it did. Oh, there it is. There we are. So, but I'm going to stop the recording so that this is not just out on the interwebs for everyone.
Goodbye.
Goodbye.